And problem 6 is talking about symmetry. And I thought, well, let me take a picture of this guy, and then I'm going to try to reflect it. See how it's like saying mirror. Well, this one would mirror and leave this one where it is. This one mirrors it and doesn't leave it like right there. So let's try that one. And I want to reflect it over a line that's right in the middle. Now, with this software, I can't really control, but I think it does reflect it right in the middle of the screen. So let's see what happens if I choose that one. Now, could you tell any difference? I mean, you can see the writing went backward, but can you tell any difference between this guy and this guy? Let me do it again. Okay, so here's the original one. Here's the one after it's been reflected. You can't tell the difference between those two. So if you reflect over this line, this right side is equal to this left side. So it just really, you can't tell the difference. So that is line symmetry. Now, you might say, well, it doesn't, like if we reflected it like this way, now it looks totally different, right? So that's just because the line that it's reflecting over is through the middle this way. You can see where the little dashed line is, right? So if I reflect it over a vertical line, then it is symmetric. So this is line symmetry, okay? So let's put that down like right here, line symmetry. Okay, this one doesn't have any symmetry, so none. I'm just going to put none there. And then I want to point out point symmetry. I didn't mean to really, I don't know, make a pun there, but I'm going to rotate about a point. Again, this program doesn't give me an option over what point to rotate. So this might look a little funny here if I try this, but I'm going to give it a shot. So I can, oh shoot, first I got to take a picture of it. So let's see, I go here, I get a picture, and I really wish I could pick that purple point to rotate about. Okay, so let me just move it over here. Now, if I rotate, I think it's going to rotate about the center of the picture. So it's not right on top of itself. That's because it was rotating about the origin. But if I did rotate about that point right there, you wouldn't be able to tell the function that I had before from the function that I have after my rotation, because it does go on forever, right? You might say, well, no, it's longer on the top now, but that arrow means it would go on forever. So, if I just line them up, this thing definitely has point symmetry. Man, I hope I'm making that clear. So point symmetry. All right. Coming down here, for what values of x is the function increasing? Okay. Increasing means from left to right, it's going up. So it looks to me like it goes up from this x value right here to this x value right here. So they're wanting us just to report the x values over which the function is increasing. So it looks to me like from -1 to about 1.5. So if I come down here and look at my options, from -1 to 1.5, ooh, this is looking the best right here. Now it does, let's check, it does increase after, they're saying after 3.3. So 3 something, yeah, I would agree with that. 3.3, see, look, the function starts low and it keeps getting higher and higher and higher. So that's definitely increasing. This is definitely increasing here. Okay, so you're going from left to right and you're trying to figure out, is the function going up? If I go from left to right, the function is going down here. So this is called decreasing. They didn't ask for where it was decreasing. It's also decreasing right in here. Again, I hope I made that clear. For which function is it true that as x approaches infinity, y approaches infinity? So here's what this is saying. As we go to the right, is the function going up? That's what it's really saying. Y is going to positive infinity as x is going to positive infinity. So here's an arrow up. We're looking for up. So that one's up. That one is not up. That one's horizontal. Oh, this one's up. Okay. Now, why am I only focused on the right side? Because it said x goes to positive infinity. Oh, here's one that's going down. We don't want that one. We want this one going up. Okay, so what do we got? We got the f of x function, the h of x function, and the k of x function. So we should bubble those 3. All right, here comes number 9. It says something about as x goes to negative infinity, where's the y going? Well, the arrow's going down, so we should put negative infinity right here. And the end behavior as x goes to positive infinity and negative infinity. That doesn't make sense, does not make sense in the real world problem. Does not make sense. And the reason why is because they said the ball started at a height of 4 feet. So right here at 4 feet, that's where it starts. And then it would stop right there because it hits the ground, right? So to have arrows on there, this whole question about end behavior doesn't make sense in the real world situation. Fill in the blanks using the available answer choices. So it wants us to tell them blank has the lesser minimum. Well, the minimum on the G function happens at 1, 2, 3, and it's 0. So the minimum value is 0. I'll put 3 comma 0, but they're really wanting to know about the Y value. And the minimum value here is 3 comma 2. So the G function, it takes a little time, lesser. So the G function is the one with the lesser minimum because it's lower. 0 is lower than 2. On number 11, it says use the key feature to sketch the graph. It's linear. Okay, linear. Oh, shoot. I got to look at my next slide, I think, to find the next one. Linear. Okay. And then it says increasing for all values of x. Okay, increasing for all values of x, increasing for all values of x, increasing for all values of x. This one's an inequality, though. So how are we going to justify it not being an inequality? Okay, so it says the x-intercept is located at 4, 0. 1, 2, 3, 0. No, 1, 2, 3, 4, 0. Yes. And 0, negative 3. 1, 2, negative 3. Oh, yeah. So this one's feeling like the right answer. Let's just eliminate this one over here. Well, this is definitely not the right x and y intercepts. And like I said, that was an inequality. So here we go. Let's pick that one right there because it has the correct x and y intercepts. That was a dead giveaway. Let's go to the next one here. Let's don't even look at the end behavior stuff. Not needed. Geez, did I skip one here? So we were doing number 11. Oh, no, I didn't skip one. Okay, that really kind of messed me up here, having that one little graph on its own. 2x minus 3y equals 6 using the x and y intercept. So this is what you do. You put a 0 in for x, and you try to solve negative 3y equals 6 because the 0 in for x made the first term go to 0. So then I say, well, negative 3 times what is positive 6? That'd have to be a negative 2. And then I plug a 0 in for y. And if I put a 0 in for y, I get 2x equals 6. And I say 2 times what is 6? Okay, that's 3. So my two intercepts are 0, negative 2. Okay, I like that one. And 3, 0, 1, 2, 3. Well, that's the first one. Bingo. Didn't have to look at any of the others. Let's go. I always like to double check. You see my eyes are looking up here. 1, 2, 3. Yeah, 3 and 0, negative 2. Yeah, I think I got it. Number 13. Which one of the inequalities is below? Well, I'm not going to use Desmos, but you could just type this into Desmos and it would show you exactly the right answer. I am going to subtract 1 from both sides. So if I subtract 1 here, 1 there, I end up with negative 2x plus 2. So that one has a y-intercept of 2. 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 Didn't eliminate a single one. It is an inequality that doesn't have an equal sign. So that eliminates this one and eliminates that one because if it had a little bar underneath, it's solid lines. My slope is negative 2. They both have a slope of negative 2, down 2 over 1, down 2 over 1. Shoot, that didn't eliminate them. The shading is going to eliminate it. See it? Like this one shades this way, this one shades this way. So in my video on inequalities, I pick the origin. And I take 0, 0, and I plug it in for y, and I plug it in for x, and I see if it's a true statement. So I get 0 on the left side. Obviously, there's only a 0 there. And then on the right side, I get 2. Well, this is a false statement. 0 is not bigger than 2. 0 is less than 2. So I do not want to shade this way, not this way. I want to shade this way. So it's definitely this one right here. So these, when I like shade in that direction, I'm saying these points would all be good because if the origin didn't work, then the other side of the line is going to work. So it's definitely the first one right there. Let's see, number 14. They're planning this birthday party. It says they charge $5 for every kid between 0 and 12 kids showing up. So it's either this one right here or the last one. Boy, I hope it's not this one right here that I can't read. Then it says they'll charge a flat fee of $18 and $2 per child. So that's this one right here, $2 per child plus 18. So it's this one right here, excuse me. What is the range of the piecewise defined function? Well, the y value here is -3. The y value here is -1. The y value here is +1. The y value here is 3. So we're looking for the one that just lists them out. It's this one right here, okay? Write an equation for that graph right there. So that is coming from the parent function, y equals absolute value of x, right? So that's the correct shape. You got to identify that first. Then we got to realize, hey, we're shifting it over 3 spots. So what I'm going to do is inside the absolute values, I'm going to put +3. Doggone it. Let me back that up. I knew I was supposed to say -3, and for some reason my mouth just wanted to say +3. I want to go -3 because it's going to give me a delay of 3. Everything is going to take like 3 longer, 3 more in the x to get to the back to the original, the parent function. The parent function would be going through the origin. Okay, so that's what that looks like. We hopefully have that in our notes, and we want to move it over 3 spots. 1, 2, 3. So -3 is going to move it to the right 3. Okay, then we want to move it up 1. So adding 1 to the y value would move that up 1. So that is the equation that should be in that box right there on that line. And number 17, how are we going to move the parabola? Let's see. They tell us the parent function. That was nice of them. Well, to move it, let's see. We're supposed to match them. That's right. So this one's going to go 5 to the left and down 3. So 5 to the left. There's 5 to the left, I think, and down 3 because it's counting by 2's, right? So this is k of x. And then this one's going to move it 3 to the right because there's a delay of 3 and down 5. So we want the one that's been moved down 5, 3, that one right there. So that's j of x. Okay, then this one's going to move it 3 to the left and down 5. So let's see, where's the 3 to the left? 3 to the left, down 5. That's that one right there, h of x. And then we want this one, 5 to the right, down 3. So let's see, 5 to the right. Yeah, that's definitely that one. 5 to the right, down 3. Yep, that's the right thing to do. I think that's it. Didn't we have just 17 questions? That's a lot. I know that's a lot. I hope you can see it well enough on your screen. I hope I made that clear. If you have any questions, just ask me. Thank you.